Lab Guy here. Sorry about the delay. It's been a couple of weeks. Welcome all new subscribers. Thank you for signing up. I appreciate that. Greetings to all of my current subscribers and old subscribers. We're starting a new series of projects with this video. I reached an end point on the Craig 6104 project, and I've passed that football to somebody else who may or may not restore the camera. Only time will tell. We'll find out. So picking it up from there, I've been busy for the last week or 10 days making money. I mean, it's important to pay the bills, right? So I've been going through the storage lockers, which I showed in a video or two back, and going through there and taking old stuff to recycling and selling as much of the items as I can find buyers for. And I did manage to get rid of some IVC components, International Video Corporation parts, and I'm currently selling some the two video switchers I showed in the previous video. And in getting those switchers ready to ship, I tested them for the buyer, and a bunch of interesting points came to the surface, which I think will make a series of projects. The third project that was in there is the Denson Electronics Monoscope, which I began testing and studying the circuits, and I've come to the conclusion that Monoscope has a built-in design bug. The video output from the Monoscope is present, but it does not contain proper sync pulses. The sync is garbage on this thing. And so vertical scanning is working, horizontal scanning is working. It's producing a video signal showing the target of the Monoscope tube, which was a character ROM, if you will, a character memory for very old radar systems from the 1960s. It contains 16 or 20 special symbols that could be displayed on a radar screen, little triangles and all the numbers 0 to 9, things like that. And Al Denson at Denson Electronics got these tubes, and he made this simple circuit to make a video generator, a low budget video generator. And somebody built this, and I got it, and I've been testing it, and as I said, the sync is wrong. The picture is there, but the television locks up with the vertical bar, the blanking, the time when the vertical should be resetting is right across the middle of the screen. Alright, so what's going on there, they get vertical sync by taking the pulse from the AC power line for 60 cycles, and then they take they have a free running oscillator for the horizontal sync, or for the horizontal scanning. And there's no sync. There are pulses, but they're not sync. And so the thing is wrong. It's outputting bad sync. Now, I could try to fight with this thing. What he does is he AC couples out of the scan circuit, off of each of the two scan oscillators, into a simple resistor capacitor filtering network, very crude, buffers it with a single triode tube, and sums this combination of pulses into the outgoing video. And it works as bad as it sounds. What I'm going to do, and this is going to upset traditionalists. Now, if you're out there and you know this circuit from Denson Electronics, I'll put the schematics on the screen. If you know this circuit and you've built it before and it works, let me know. Let me know. But here's my answer to the problem. I'm going to put my my Fairchild 3262 sync generator chip in there to synchronize the two oscillators, and since it outputs blanking and composite sync, I will use its blanking and composite sync to drive the video output tube in the Denson Monoscope and bypass trying to create the sync off of the scanning oscillators, which is very crude to begin with, and clearly it's not working. Now, I don't know if I checked the wiring, by the way. It matches the schematic from Denson perfectly. So whoever built this did a beautiful job. And so it's not a wiring error, but they must have been very frustrated near the end. This thing won't even lock up a black and white monitor, which are very tolerant to bad sync. Anyways, let me show it to you so for those who haven't seen the video will know what I'm talking about. A monoscope is a kind of camera that has a camera tube right here that has a built-in picture. It's printed on a metal plate, and the electron beam scans the metal plate, and the result is a signal. There's carbon ink on the plate, and when the beam scans over the carbon, the output current drops, and when it's striking metal directly, the output current goes up, and this produces a video signal as the beam scans. So it's a very simple process. If you're familiar with my project called The Chief, you'll know that it works the same way, and that's the monoscope that has the tube with the Indian head test pattern in it. So this was very well built by somebody way back. I don't know when. This to me looks like 1970s construction of the purest form, and it is constructed by somebody who really knew their stuff. This is a well-built unit. Now, let's look at this. Let's look at the schematic, and you'll see that it's an all-vacuum tube, free-running design with a free-running horizontal oscillator and a vertical oscillator that is synchronized with the power line. So as I said, I'm going to put a proper sync generator in there and fix those issues and make that thing work, because the person who built this deserves this thing to be finally finished. I don't think that they had a solution for the problem themselves, or if they did, they reached a point of maximum disgust, as I've done on some projects, Craig, and they just put the thing aside and didn't waste any more time on it. So, having talked about the Denson Monoscope, putting a sync generator in it, this whole subject came up because of that and those Sony video switchers. And so in the process of working with the Sony switchers, it brought me back around full circle to my favorite things, Portapak video cameras. These have the 10-pin plug, which used to plug into a portable video tape recorder, and the black and white cameras specifically, the tape recorder sends horizontal and vertical drive up to the camera to synchronize the camera tube and the little 1-inch TV monitor inside. This is the AVC 3400 from Sony. This is his papa. This is the DVC 2400 from Sony with the wrong lens on it. And it also has the 10-pin connector. This one is 1967. The AVC 3400 is 1969. And then there's the final AVC 3250 from Sony, which was the upgrade of the 3400. It's lighter. It's 4 pounds versus 7 pounds for the 3400. Exact same connectors, same sync system, same 1-inch viewfinder, zoom lens, and The 3400 and the 3450 use a vertical sync pulse and a horizontal sync pulse, a square pulse. The 2400 uses a vertical sync pulse. They're all the same on the vertical sync, but the 2400 takes a sine wave at 15 3/4 kilohertz for sync. So we'll be looking at each of those cameras in turn as we develop an adapter that will allow them to be used with a real proper sync generator. This is a commercially made video sync generator made by Sigma, and it puts out all of your pulses that you need. It puts out composite sync, it puts out color subcarrier, composite blanking, the burst flag, which is used to gate subcarrier into the sync period, horizontal drive, which drives your horizontal scanning oscillator, vertical drive for your vertical scanning oscillator, and a black burst signal, which is a complete video signal with everything in it except video. It's a black video signal, and that is used to synchronize other video devices. So this is a master sync generator unit. You can find these around. This is made by Sigma. It's a CSG 160. I have two of them. One of them works. The other one may or may not work. I based my presumption that it doesn't work on the fact that the LED on the front doesn't light up. Well, this thing is sticking out a foot, and it could have been bumped, and the LED isn't lighting up. The rest of it's working. I haven't tested that. So anyways, we're starting with this, and it outputs industry standard sync pulses from the 60s, 50s, and 60s. That is a spec that the voltage of that waveform is 4 volts peak to peak negative. So it essentially goes from 0 volts DC to negative 4 volts. And what I've measured, it goes from 0.25 volts positive to minus 3 3/4 volts negative. It's still 4 volts peak to peak. It's DC referenced at around 0 volts. It's a 1/4 volt positive. We can call that 0 volts and get away with it. So I'll be developing what's called a level shifting circuit to level shift that type of drive up to the 12 volt drive that those cameras want to see, and I'll be shifting it to whatever the heck the Denson Monoscope needs to make it synchronize. I'll be working on its oscillators one at a time and making them synchronize. Then I will work on adding the composite sync and blanking together to the output video on that. That will be an ongoing project. But I will be working early on trying to make the Sony 3400 camera work. I believe I may have a video, an old video where I did that to this camera, but we'll see. So that is the status of where my projects are at, and because of, as I mentioned, the money making by selling stuff from my storage lockers, part of my time that got consumed. It has come to this. So this is a nice logical progression. In the next video, we'll probably look at the sync generator itself and the output signals and work on shifting them to more usable values, like changing them from negative going below ground voltages and shifting them up to above ground voltages. And I'll also show you how to flip the polarity of them for your needs for driving various video devices that you may want to construct. Think about a home-built Pong game. Pong was a very simple thing. It starts with a sync generator producing sync pulses, and very little circuitry is needed to make 2 paddles on the screen and the moving ball. It's amazingly simple. So we'll talk about that at some future point also. So I think that pretty much covers it. thank you all for watching again. I appreciate your viewership. You guys rock. And you know what to do if you like the videos. And I won't insult your intelligence by telling you, oh, you should push this button, like all the other videos do. As you've learned about me as I make my videos, I don't like cliches, and I don't like repetitive things that people say over and over. You'll never catch me doing that. Key operative here, you'll never catch me. So, until next time, Lab Guy out.